Inequalities. There are expressions of rational functions that are not equal to something else. It can be solved similar to solving polynomial inequalities, but the only difference is that the numerator and the denominator are polynomials that have to be taken into account. Here is a rational function inequality. Bear in mind that if one of the sides isn't zero, move everything to one side to get a zero on the other side. The side that just got everything moved should be simplified, one polynomial on top of another. First off, factor the numerator and the denominator to find these endpoints of intervals. These will be intervals that can be used to determine where the function will be greater or less than 0, as well as the s-intercepts of the function. Next, find the 0 of these factors, and we will have these very important numbers. Now, make an interval table like shown, where the intervals are put in an ascending order similar to a number line. Exclude where the value is at one of those unfortunate numbers. Plug in x values that falls between an interval. For example, negative x for x is smaller than negative 7, negative 2.5 for x between negative 3 and negative 2. Then solve the function. Here, when x is at negative 2.5, the function is positive. Thus, the interval x is between negative 3 and negative 2 gives a positive value, and the sign of the function there is positive. Repeat for other intervals. Now, depending on the comparative sign, choose your intervals. If the inequality tells you to solve x where f of x is smaller than 0, find domain intervals where it is negative, and vice versa.